Welcome to our next segment of high school geometry with Mrs. Netz and Mrs. Weichel. This is Mrs. Netz.
And this is Mrs. Weichel. Thank you for introducing me.
Not a problem. Today we are going to introduce 1.4 polygons. Our learning target for today is by the end of this lesson, I will be able to understand the properties of different polygons and how to apply that understanding to everyday life. Why is this important? Because understanding area, surface area, perimeter, and those kinds of things are not just important to future lessons, but they're also important to just living in general. How will you know that you know it? Well, when you can solve for different angle measures on different types of polygons. So we're going to go ahead and get started with the definition of
what a polygon is.
Let's go.
So a polygon is a two-dimensional shape. It's a closed figure and it has to have straight sides. So you guys have some space underneath the word polygon and underneath after you fill in the blanks to actually show some polygons. I have some already drawn here. So as long as you have straight sides and they all meet up on the ends, it's a polygon. So right here, this would be a polygon.
So you could copy this one and put it in your notes and you could write polygon, absolutely a polygon.
Right here, that would be a polygon because the sides are straight and all the ends meet up. What would not be a polygon are these two because they are not straight sides.
These get a little bit confusing because a lot of people think, oh, it's another one of our shapes, but yeah, it's not a polygon.
It's not a polygon. And then the last one, even though the sides are straight, there is an open gap here, so this would actually also be not an example of a polygon. So a polygon must have straight sides and the ends of those sides must be attached to one another.
Okay, so next we have a table, and if you'll notice, it's got 6 columns going across. We've got our shape, then we've got, it's asking you how many sides does that shape have, and then what is the name of that shape. What we would like for you to do is we'd like for you to pause the video, go ahead and write in the number of sides each one of those shapes has, and then if you can, go ahead and write in the name of that polygon.
So if you need to Google it, please go ahead and do that. We want what is the name of it.
Okay, so if you're unsure as to what, if we had, for example, one here that had 50 sides, you would Google what is a 50-sided polygon called. So if you would go ahead and fill out this table when you're all done, unpause the video, and we can check to see how you did.
Okay, so hopefully this table is completely filled out for you guys. We simply wanted you to count the number of sides. You should have gotten that this is 1, 2, 3 sides, 1, 2, 3, 4 sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then you should have looked up what the names of these sides would be. This, because of what it looks like, it is not just a triangle, it actually is an equilateral triangle. Whoops. Right here, this is a quadrilateral, but it is 4 same sides with right angles, so we would actually say that that is a square. A 5-sided polygon is called a pentagon. Then we have hexagon, heptagon. 8 sides would be octagon. 9 sides is nonagon. 10 sides is decagon. 11 sides is undecagon, and 12 is dodecagon. So go ahead and make sure those are filled in correctly, please.
With your undecagon and dodecagon, if you were to write the number 11 and then write dash gon, 11 gon, or 12 gon, anything really above a decagon, you could write the number of sides and then write the word gon, and that would be fine.
Like, for example, you can see right here, if I pick this one, this is a 16-sided polygon. It's very hard to see those sides. The more sides you add in, the more it looks like a circle. You would just say that we would name this as a 16-gon. Any sided shape, any side polygon would be an, if you have n sides, it would be an n-gon, whatever the number of sides are.
Okay, now back on your table, something to note here is every one of these shapes that we have here all have every single side the same measurement.
And every angle the same measurement, which leads us into our next vocabulary word, which is a regular polygon.
So think about when I say regular intervals or this happens regularly. Basically what we're saying is we're saying that it happens at a set period amount of time. So if I say a regular polygon, I'm saying that all the sides are regular or the same, and all the angles are the same measure or congruent.
So you can see here, I started highlighting them, I'll do it again. These sides all have this like tick mark through it. That is showing that all 6 sides are the exact same. These little angle measurements are showing that whatever degree one of them is, they all have the same exact degree. So because of all those relationships being the same, we would say that that is a regular hexagon. Whereas over here, this is definitely not the same length as this. So while they're both hexagons, the one on the left is a regular hexagon. The one on the right we would say is irregular because it does not have the same side lengths or angle measurements.
Now definitely make note of the congruency marks. Notice the single tick mark. Everywhere you see a single tick mark, it's saying that it is congruent or the same as everywhere else that has a single tick mark. You'll notice on the angles it has a double tick mark, and we're using a double because a single has already been taken. So everywhere you see that double tick mark, they're saying it is the same or congruent. Now, an irregular polygon can have congruency, but all the sides are not congruent. So for example, I could have this side right here be congruent to this side over here, but they're definitely not congruent to that very long side on the top. So this is not a regular polygon.
For a regular polygon to be true, all the sides must be the same and all the angles must be the same.
Okay.
So go ahead and turn your notes over. Now we're going to talk about the parts of polygons, and this goes for mostly irregular and regular. It doesn't matter which you have. They will all have something called an exterior angle. An exterior angle is an angle formed by one side of the polygon and the extension of a side. So I've given you, I've given you a triangle, and you can see within this triangle here is a side of the triangle, and then the bottom, if I extend it beyond the vertex point, you can see that it is making this exterior angle here.
So basically what you're seeing in that yellow highlighting was what you see similar to the image that you see in your notes. Here in the video you see we have extended all 3 sides of the triangle, so that way you can see all the exterior angles.
Interesting, I think an interesting property is that no matter the polygon, the easiest test question if you can remember this, all exterior angles, no matter how many of them there are, will always equal 360 when you add them together.
So doesn't matter if it is a octagon, a nonagon, an undecagon,
A 100-gon,
a 1,000,000-gon.
The exterior angles will always add up to 360 degrees. And mostly it's because as you're going around, as you add sides, what did I say it starts to look like?
It's going to start to look more and more like a circle.
And so those exterior angles are going to approach that mark. If you have a regular polygon, so I said that this backside goes for both irregular and regular. If we're talking specifically about a regular polygon, so remember that means all your sides and all your angles are the same. You are able to find what one of the angle measurements is by dividing the sum, which is 360, by the number of sides. So you can go ahead and fill that in, 360 divided by n. So like in the example I'm giving you, if that were an equilateral triangle, I would just do 360 divided by 3, and that would give me 120 degrees. So in the picture you've seen on the screen, I know angle 1, 2, and 3 all equal 120 degrees. So if there's an exterior angle, there's also going to be an interior angle. And an interior angle is going to be an angle formed by 2 sides of a polygon. You have an example of a pentagon. that you can look at. I have an example of 1, 2, 3, 4, 5. Also a pentagon, just a little different looking than yours. But you can see all 5 of these angles are interior because they are on the inside of the shape. 2 sides are forming angle E. 2 sides are forming angle D. 2 sides are forming angle C, and so on. Properties: an exterior angle and its adjacent angle form a linear pair, so they are supplementary. So an exterior and interior angle pair, they're always going to add up to 180 degrees because they are a linear pair.
So for example, if we go back to our example with the triangle, if you look at the exterior angle and then look at the interior angle, you'll see what we are talking about with the outside angle and the inside angle together form a linear pair. Therefore, they equal 180 together.
So it's very easy to actually find an interior angle this way as well. We already talked about how 360 divided by 3 makes this a 120 degree angle. Well, what's 120 minus 180, I'm sorry, minus 120? 60. So angle 4, or these 3 interior angles, must be 60 degrees.
Okay. So,
and using that logic is actually where our next part comes from. If you work it out, it uses the relationship of interior and exterior being supplementary. The sum of all interior angles is found by this formula. N being the number of sides, take away 2. There are a set of parentheses around that, so you would need to do number of sides minus 2 first. And whatever that difference is, you're going to multiply by 180. That number is what all the interior angles will add up to equal. That works for both regular and irregular polygons. So if you have a regular hexagon and an irregular hexagon, their sum for interior angles are going to be the same. Where it starts to differ is for the regular polygons, all 6 angles will be the same exact number, whereas for an irregular, while they add up to the same thing, each one can be different. So to find one interior angle, you would have to have a regular polygon. You would take the sum, which is that n minus 2 times 180, and you would divide it by the number of sides, very similar to how you found one exterior angle for a regular polygon. And that's it. Very short lesson.
Can you believe that? We are like stealthy today.
So hopefully you guys feel on a range of red, yellow, and green, more towards down here. Of course, if you are in the yellow or red, please reach out to Miss Netz or myself or your own teacher if we are not your teacher.
Yeah, you can do that. Hey, Mrs. Weichel, I think we have a problem.
What's your problem?
Well, a lot of students think that a polygon is a missing parrot.
Polygon is a missing parrot.
Get it?
Where'd Polly go?
Yeah, she's gone.
Polly gone. All right, this is Mrs. Weichel.
This is Mrs. Netz.
Thank you for joining us. We
And-
will see you in 1.5.